Okay, so so for that line, right, that's going to pass through the points 1, 2, and 2, 6, right? Here's 1, 2. This is 2, 6, right? Passing through that. So let's calculate the slope, right? So here, well, what the heck? This is red, but that's okay. We have 6 minus 2, right? We have a change in y. But again, you have to subtract by the corresponding change in x from the second point to the first point for y. So we do the same thing for x. Second point minus 2 minus 1, that is. Right? You have to be careful because it's subtraction. But you get 4 over 1, which is 4. So notice a few things. For 1, both of these lines have a positive slope, okay? Both have a positive slope. And notice that if we were to walk along the x-axis, the horizontal axis to the right, like the laser thing is doing, towards increasing numbers, right? What are these lines doing? They're climbing. They're moving up and to the right. Up and to the right. Or if you think about north, south, east, and west, they're going northeast, right? They're going up to the right. Well, that's no coincidence. A line with a positive slope will move northeast, so to say. That is, as you walk along the x-axis towards bigger numbers to the right, a line with a positive slope is going to move up and to the right. Not up and to the right, excuse me, it's going to move up to the right. It's going to climb, in other words. Maybe that's better. That's actually what happened over here, right? This line has a positive slope. As you move to the right along the x-axis, what's this line doing? It's climbing. It's moving up to the right, as you can see. And that's no accident. Lines with a positive slope are going to do that. But what else is happening? This line here, the blue line, this line here, the slope is bigger. And it's closer to being vertical. It's steeper. That's no accident either. The bigger the slope of a line is, the steeper it's going to be. If they're both positive, the steeper it's going to be. You know, it's going to be closer to being vertical. Are there any questions about that? This is what I was trying to say over here before in last class, right? If you have a pair of points, as you move towards increasing x, well, the line, it's going to climb if it has a positive slope. That is, if the y coordinate is also going to increase, right? Then the line is going to climb and it's going to have a positive slope. That's what I was trying to say over here and in previous class. I mean, hopefully I was successful. But now let's consider Now let's consider these lines. So here's a little bit different. They're both passing. These are two different lines passing through 1, 2. But now they're passing through 4, 1 and 4, negative 4. Okay, well, let's calculate the slopes. The green line now is passing through 1, 2 and 4, negative 4, as you can see. What's the slope going to be? Well, change in y. So let's do negative 4 minus 2. Right? So from the second to the first point. And then we divide by the corresponding change in x. So we have 4 minus 1. Corresponding change in x. Negative 4 minus 2 on top. 4 minus 1 on the bottom. Negative 6 over 3, which is -2. Okay. So this line has a negative slope now. Okay, that's cool. Let's look now at the blue line, the other line that is. So we're going to look at this line now. We handled this line. Let's look at this line. Okay, so this line is going to pass through the points. It's passing through 1, 2, and 4, -1. So let's get the slope. We have, let me change the color a bit though. So now we have we have -1 -2, like so. But again, now we have to do the corresponding change in x. So we're going from the second point to the first point. Let's do the same thing for the x. 4 - 1. -1 - 2, 4 - 1. And here we get -3/3, which is -1. So both of these lines have a negative slope. Right? And notice what they're doing. Now, if we were to walk towards the right along the x-axis, right? If we're walking to the right, these lines are going to fall. They're going down to the right, down to the right. That's the direction they're pointing. In other words, the lines are falling. Or again, if you think about directions like north, south, south, east, they're going southeast in that case. So that's what these lines are doing. Not only that, notice the green line, the slope is smaller, right? It's more negative, and this line is steeper. It's closer to being vertical. Well, that's no accident either. The more negative the slope of a line is, the more, how do I say it, the steeper it's going to be. The steeper it is. Okay, so to summarize these observations we made, we have this. Any line with a positive slope, right, that line's going to rise as you move to the right. As you move to the right along the x-axis. Okay. That's what's going to happen there. And the bigger the slope is, the more vertical the line is. In other words, the steeper the line is. With a negative slope, instead of climbing, the line's going to fall. Okay, it's going to fall. And the more negative it is, the more vertical the line is. So that's what's going to happen in this case. No, so these are just good observations. So, okay. Are there any questions on this? Okay. Now remember, we said a line, right? It's the graph of an equation. Well, there's different ways of writing that equation. You know, if you're given a line, in other words, that's drawn in the Cartesian plane, assuming the line is not vertical, there are different ways of writing an equation of that line. And one of them is using point slope form. One of them, excuse me, let me say it differently. Let me say it correctly, that is. One of the ways of writing that line is in point slope form. Point slope form. And how does that point slope form look like? Well, suppose the line has a slope m, and let's say it passes through this point, AB, whatever it is. So the line has slope m, right? Again, the line is not vertical. You know, if it's vertical, it doesn't have a slope. Passes through this point. The point slope form of an equation of that line is this. You have y minus the y coordinate of the point is the slope times x minus the x coordinate. That's what we have here. So for instance, if you look at the first line, right? The line that went through 1, 2, let me just get to it, and 2, 4, that was the, what was that? That was the green line here. That line goes through points 1, 2, and 2, 4. We can get the point slope form of that line, of the equation of that line. Why did I write formula? We can get the point slope form of an equation of that line. Right? We know the slope is 2, and we can really use either point. If we use 1, 2, right, we would have y minus 2, right? This is the y coordinate, equals the slope 2 times x minus 1. 1 is the x coordinate.